Okay, so in our previous video, we did all the unboxing of our amazing McFarlane cables, and we just finished the installation of the cabin air controls. Right. So how the cabin air and heat works is we have a fan and heater box that takes the coolant.
Air box, kind of heater core.
Yep, so it takes the heat from the coolant, passes it over the air, and that's how we get the heat. And the heat goes two ways. One to the feet, or to our feet in the footwell, and other to a mixing box that can take ram air and air from the heater box and can mix that so we can control the temperature for both the front pilot as well as the co-pilot in the back seat.
Right, and so that's controlled in a couple of ways. You've got the air box for mixing, you've got ram air coming outside, that's our outside air through a scoop on the top of the cowl, and then you've got those control nozzles where there's two for the pilot in the front, there's one for the passenger and co-pilot in the back, and so a lot of air control going on here. Now, we wanted to do a video like we usually do where we take you through all the different steps in the process and have you watch it, and there's some video and there's some showing it, but I will tell you, of all the things that we have done so far on the Mustang, the main one that we've done that requires two hands and two people, four hands and two people, and the most coordination I've ever seen has been getting cables installed in this, because so much of the plane is already built and we have to get alignment and sheaths and 8L clamps and put it through the little, like, cable lock at the very end, and so you've got one person on top, one person underneath.
And we're starting to see our access as we start building the plane,
dwindle.
Yep. So
we tried to film some of it, and it was just ridiculous because trying to get where your hands are, and literally I'm like, okay, where's my hand now? And you're like, move 1 inch this way. You try to put a cable end through a hole. Where's the hole? Don't worry, just move a little bit more in this direction. But we did it, man.
Yep. And so how it works is we have our instrument panel up here, and we have a little control panel where all of the kind of control for the cabin air, heat, temperature, everything like that can be kind of manipulated. So down in this kind of right corner, we have a switch for the fan speed. We can run that. So that's the fan speed coming off the heater box.
Yep.
We can use that, but we also said there's a potential in the summer for us to maybe do some routing and maybe have an ability to have air running through the cabin without heating. So that's an option too.
We're going to be able to shut off the coolant flow through the heater core.
Yep.
And then use it that way, and just have it as fresh air blowing when you're on the ground if you don't have enough air or something like that. And as a little teaser, we have some ideas about how we might be able in the summer to switch it over and run a really cold liquid like ice water. You've seen those systems in airplanes through it, and it would serve the same function. So different ideas, of course, for in that case cooling for that. But Jake made this really cool environmental systems panel for all of our controls, and McFarlane went and custom engraved and painted the ones that say cabin air pull hot, floor heat pull on. Man, it looks good.
Yeah, so we have our two cables right here. The top one does the temperature in that kind of mixing box that we have up behind the panel, and then this bottom one kind of runs all the way down to the floor and gets directly heat.
So let's talk about design. Jake, why don't you explain to everybody, when you're working with cables, especially these McFarlane cables which are push button lock, they have this great feature. You just click it. It's like a positive click, and then you can move it anywhere you want to, and then you let go and it's locked. It's not going anywhere. Explain to people the process for how you size cables, how you cut them down. How does this little locking mechanism work?
So the first thing is kind of the components of the cable. So you have the sheathing on the outside, and in McFarlane's case, it has a Teflon kind of liner inside, which is going to help the durability.
Makes a huge difference.
And it's a lot smoother as well.
Generic cables. Oh yeah.
And inside that sheathing, then you actually have that metal cable that goes through, and that's what you're actually controlling. So the sheathing is fixed, and you can fix that with ADL clamps, which is what we did in this plane. And then you have the cable that moves through, and you have the
solid core wire, because that's what this kind of is.
Yep. And so that is what you're kind of manipulating, and when you can push the button, then it'll stop in that position. So what we did is we put the sheathing through, and without the cable through it, and you can size that up. Then you cut it to length, and then you kind of make the sheathing straight, push the center core through, and start sizing that. And in order to size that, what you can do is you push the cable all the way kind of forward into the sheathing, and then back off a little bit, and maybe give it somewhere between 1/8 or 1/4 of an inch. And that's kind of your cushion.
Right.
Then when you go back in the plane, wherever you're controlling that, you kind of set that as your max limit. So in our case, we wanted the control fully closed.
Yeah.
So we set that as our limit. Now we have a cushion, so we're not bottoming out at the control side. We're bottoming out at the actual flapper side.
The lever, whatever you're doing. Cushion is a really important thing. This is something that you should be doing on all general aviation aircraft, all aircraft for that matter. Anytime you've got a control, whether it's a throttle, mixture, prop, air, it doesn't matter what it is in the aircraft, you never want the handle, the knob, or the control to go all the way and hit the panel or dash or go to its full distance. Never want that. If that's the case in your aircraft, you should adjust it, because that hitting a stop before you go all the way in, that's your confirmation. That lets you know that the arm that you're controlling on whatever it is, whether it's the throttle we said, any of the other stuff, that lets you know you've hit the mechanical stop, the real stop of what you're controlling. That's really important. So of course we built cushion in to how we do our air controls here as well. Now, why don't you explain to people how McFarlane's push lock system works, because you get really intimate with this when you're working with the cable.
So in this kind of front section, there's actually two pieces, and you can't see it, but maybe we can show a shot of it. And in the back side, you have kind of the sheathing, and then it has that
the rigid tube portion.
So you have the rigid tube portion, and you have the front,
like the
plastic kind of center. And that stays fixed kind of with the cable that goes through. You then have the push button, which is spring loaded. That goes inside and kind of has a little groove. And what ends up happening is there's a little, kind of looks like a little ball bearing. And you kind of slip that into the hole inside of the...
When you're pushing the button shut, if you squeeze it, the ball bearing will fall into place.
Yeah, so you have kind of that little ball bearing that fits in. When you push it, it'll fall all the way in. And when you pull out, it kind of raises it up a little bit and ends up locking the system in place. So that's kind of how the locking mechanism works.
It's cool because you can get right into it. You see how it works. Like, you know, you're a mechanical engineer. Like, that's what you're in school for. So getting to see how you create a system where you push it and you can move it freely, you let it go and it's locked. What did you think about getting to see how they built it?
Yeah, it was really cool how how it was manufactured, and also the kind of design that went in. It's a really, really simple system because you basically have the cable, the push button, and a little hole, and all it's doing is raising up and lowering that ball. And so it's a really simple system, but it works really well, and it's locked in place with that, that push button not engaged.
Yeah.
The other thing that we learned, if you are installing these cables, is so you put the sheathing through and you cut that to length because you don't want to cut both the core as well as the sheathing. However, when you then start pushing the core through, what we found out is you want to make sure that the sheathing is straight enough that the core can go all the way through smoothly, especially with these where you have kind of a Teflon liner on the inside. What ends up happening is if you have the sheathing kind of routed through the aircraft, and then you start pushing the core through once you've cut.
With a really, really sharp, just cut wire.
Yeah. What you end up doing is you start kind of cutting away that sheathing that you're paying for.
We didn't do that at all.
So we definitely did not see any blue powder on the other side.
No blue shavings that came out. We do everything right the first time. We know what we're doing.
But we learned before we start getting to the real...
That's right. Air cables first.
Yeah.
Environmental systems. And now we'll start working on emergency systems now that we are absolute experts in how to work on all this.
So,
excellent.
Yeah.
You have a good time?
Oh yeah, it was great. And we are one step closer because basically we need to keep finishing out the front end internal components so we can then, you know, finish out the skin, finish out the canopy, and hopefully we can get the plane out of the house soon.
You guys got to understand two things. First of all, we're scared about closing up. We're at this stage where every time you close something out, you have no more access to it after you rivet it all up, close it all up. And so we're constantly thinking like, okay, are we ready to put the windshield back on, or ready to put the top, you know, of the nose bowl, or this whole thing back on the front of the cowl? And it's like, yeah. And then right after that, we're going to realize that we need 6-foot arms in order to get down and finish something that we forgot. So that, anyway, we're doing that. And then, of course, the other thing is that when this is no longer inside of our living room and our dining room, we're going to miss that.
Mm-hmm.
Yeah,
we
know. Now, there'll be other parts of the plane that come in. Anyway, thank you so much for watching. We will be back with another episode on our T-51D Mustang build, and that will be when we use more of these cables for the emergency systems that we're about to put in. That's what's next. So until next time, I'm Jeff Simon for SocialFlight.
I'm Jake, also from SocialFlight.
And please check out SocialFlight.com and the free SocialFlight mobile apps for Apple and Android devices. We have tens of thousands of aviation events and destinations. And every Tuesday evening, we have SocialFlight Live. Just go to SocialFlightLive.com and you can see some amazing guests that we have coming on to the show. Until next time, wish you all blue skies.
Okay, so we are on to, oh wait, what should we say? We're not on to another step, but we're a little closer. Okay, ready?
No.
Okay.
You could just say.
Okay, I'm starting over. The heat coming out of the,
Yeah. Okay, so here's what happened. We got... This would make a good video if we just leave it like this.
Nah, I don't think so.
I know.
Okay.
This is what it's like making a video with Jake. You ready?
Ready? Okay.